Roxana, I am so excited for this session. So Roxana comes to cybersecurity via being a developer, a front-end developer, and she kind of found a passion for making sure that the applications that she develops are secure. So she's gone down this really interesting path of learning cybersecurity, and she's going to talk about that today.
Thank you so much, Christine, for such a beautiful introduction. And thank you to the entire team at APIESC for inviting me and organizing a great event like every time. Hello, everyone. I appreciate you taking the time to tune in for my session. I hope you will find it enjoyable. Today, we're going to talk about safely consuming third-party APIs. But before I dive into the details, allow me to reintroduce myself. I'm Roxana, a freelance front-end developer specializing in Next.js. But before coding, I spent 5 years crafting copy for cybersecurity vendors. Now, this past experience has helped me get started with developing a security mindset even before I learned to code. So it's probably unsurprising that in my current work, I focus on honing secure coding habits and building expertise in API security. Since third-party API integration has been a recurring part of my work as a front-end developer, in this session, I will cover why headless architecture is popular, how third-party APIs fit into this architecture, why trusting those APIs blindly can have serious security implications. Then I will go through a couple of recent large enterprise breaches, exemplifying unsafe consumption of APIs and what developers can learn from those breaches. Finally, I will share a brief threat modeling exercise, free tools, and best practices that freelance and small team developers can use to embed API security into their workflows. Now, I hope I piqued your interest, so let's dive into today's topic. Why is headless architecture popular? So in a headless architecture, the front end communicates with the backend through APIs. This allows for greater flexibility and scalability as developers can choose the best tools for each part of the application. Third-party APIs are commonly used in headless architectures to add functionality or data to a web application without having to build it from scratch. For example, a developer might use a payment gateway API to handle payments, an SMS OTP API for account password reset, or a social login API to allow users to log in with their social media accounts. However, integrating third-party APIs also introduces security risks. So if a third-party API is compromised or vulnerable, it can lead to data breaches, financial loss, service disruption for the web application that relies on it. Now, why does this happen? According to the OWASP, developers tend to trust data received from third-party APIs more than they do user input. And this is especially true for APIs offered by well-known companies. Because of that, developers tend to adopt weaker security standards, for instance, in regards to input validation and sanitization. To illustrate how unsafe consumption of APIs can affect any company, regardless of size or industry, let's take a look at a couple of recent examples. And the first one we're going to talk is CoinMarketCap API drift. CoinMarketCap is the most popular website for tracking cryptocurrency prices. And for those unfamiliar with the term, API drift describes the gradual unintended divergence between an API's published contract and its actual behavior that the service implements at runtime. This breach occurred in June of this year. So what happened? CoinMarketCap's homepage features a rotating doodle image. This feature uses a third-party API to dynamically pull the image for its homepage. Attackers manipulated the backend API responsible for serving those images to deliver a tampered JSON payload that it embedded unauthorized JavaScript into the site's frontend. When users visited the homepage, the malicious script executed, triggering a pop-up that mimicked a legitimate wallet verification request. The pop-up urged visitors to verify wallet, which was a tactic used to gain access to users' crypto holdings. Luckily, though, no funds were stolen, and the security team at CoinMarketCap responded promptly. But the incident highlighted the risks associated with API drift and relying on third party APIs without proper validation and monitoring. Having said this, API drift is a real threat. Developers should not assume that a third party API will always behave as expected. It's a good practice to review and test third party APIs to ensure they haven't changed in ways that could introduce vulnerabilities. For this, a developer can use Postman to simulate calls or write unit tests using Jest or any other testing framework to ensure API integrations behave as expected. The next breach I want us to cover happened in December 2023, and Hugging Face is the GitHub for AI developers. And one of its most used features is its API, which allows developers and organizations to integrate models to read, create, modify, and delete repositories within them. So, what happened here? Using the search functionality in GitHub and Hugging Face, security researchers discovered that over 1,600 API tokens were exposed in public repositories. These tokens provided access to a variety of machine learning models and datasets. The incident could have led to catastrophic consequences, including data breaches and the spread of malicious models affecting millions of users. Fortunately, developers and the repository's users mitigated the issue promptly, narrowly avoiding a disaster. While this incident took a positive turn, it reveals the persistence of a developer's bad practice. The API keys in Hugging Face were exposed because developers were storing their logging information, including API keys, in public repositories. The takeaway here is the following. When consuming third party APIs, developers should be aware of third party API usage. They should have multiple API keys, rotate them frequently, and ensure that they don't hard code their API keys in their code base or store them in public repositories. So, what else can developers draw from these incidents? Whether your freelance work serves small businesses or you work for a large company, organizations of any size can be vulnerable to unsafe consumption of APIs if developers don't understand it and don't adhere to best practices when integrating third party APIs. The CoinMarketCap breach we discussed earlier shows that any third party API can be turned into an attack vector the moment it's compromised. According to Verizon's 2025 data breach report, small and medium businesses are 4 times more targeted than large companies. That's because they may have weaker security measures in place compared to large organizations. Therefore, a company with just a handful of employees can suffer an outsized damage, including financial loss, legal liabilities, or even out of business. Considering everything we covered so far, where does a developer even start to prevent API 10 unsafe consumption of APIs? And my answer is threat modeling. I like to see threat modeling as a negative visualization exercise in the sense that before a developer starts writing even a single line of code, they should think about what could go wrong in their app and how can they prevent that. However, to imagine what can go wrong, a developer has to first be aware of what can go wrong. And this is where taking code security or API security courses comes into play. They help developers think like an attacker and understand how to prevent various vulnerabilities. According to the OWASP Application Security Verification Standard, most threats to applications come from attackers who use simple, usually automated, and low effort techniques to identify easy to find and easy to exploit vulnerabilities. Therefore, as a developer, being familiar with preventing the most common vulnerabilities first and identifying risks early on can go a long way in preventing unsafe consumption of APIs. To create a threat modeling exercise, Adam Shostak's framework is recommended in the industry as it's simple and effective. It basically consists of 4 steps. What are you building? What can go wrong? What are you doing about it? And did you do a good job? And if you'd like to learn more details about this framework, please consult Adam's books and blog posts. Tanya Janka, whom I greatly admire, also has useful resources on threat modeling for developers. But to keep things simple in this session, let's take a look at what makes a developer suited to do threat modeling. So, as a developer, you know best what you want to build and what third-party APIs you plan to integrate in your web app. And if you have no security person on whose expertise to rely on, the responsibility to protect your web app falls on you. It's important to note that threat modeling is not a one-time event. It can be an ongoing process that you can start small and gradually build on it. So when it comes to preventing unsafe consumption of APIs, as a developer, you have 2 components to consider: what you cannot control and what you can control. Despite the fact that as a developer, it's recommended that you use APIs from reputable companies with a great track of record of security-wise, essentially third-party APIs is code that you do not own, nor you can control the security posture of its provider. However, what you can control is how your app consumes this API. With these considerations in mind, you can then take protective measures in your app to ensure it consumes the third-party API as safely as possible. To bring together all of the points we discussed so far, let's see what a brief threat modeling exercise could look like for a simple web app. But before doing that, it's worth noting that threat modeling is context-specific, meaning the threats and mitigations will vary based on the specific web app and the APIs it consumes. A very helpful way to start the threat modeling exercise is to create a simple diagram of the app architecture, including the third-party APIs it consumes. The goal here is really to identify the components of the app, how they interact with each other, where the third-party APIs fit in, to have a clear picture of the assets that need protection, to identify potential threats and map them to actionable mitigations. Tooling-wise, I'm using Excalidraw, but any diagramming tool would do for this. For this threat modeling exercise I'll go through, I chose to keep it simple, but in a real-world scenario, the diagram would be more detailed, including specific endpoints, data flows, and security controls. So I'll use a simple web app example to illustrate how a developer could approach preventing unsafe consumption of APIs in a specific context. So we have here an e-commerce web app that sells tea products. It has a headless architecture where the front end is built with Next.js and the back end is handled by an API-first e-commerce provider, which could be any of the popular ones out there. It could be Swell, Snipcart, or any other. So here I'm showing the product page on the live website. The data is fetched from the e-commerce provider and rendered dynamically in the front end. This view is the store owner dashboard and how they set product description, which is HTML formatted, meaning they can add links, images, and so on. And the final view is the API backend that the web app calls to get the product data in a JSON format. So what can go wrong in here? We can assume that the e-commerce provider API is compromised. It passes malicious data to its consumers due to insufficient internal controls. The web app assumes that the API is safe and consumes the fetched data without sanitization. The malicious script is executed in the front end, and this could potentially lead to data breach, service disruption, and so on. Now, the developer fetches the data from the e-commerce API on the server because they learned that it's more secure than fetching it client-side. And this is a good first step. However, this simply reduces the attack surface, but it doesn't prevent API 10. Given the fact that the e-commerce provider API formats the product description in HTML, the dev wants to dynamically render this description. For this, the developer uses dangerously set inner HTML in the product component to render the HTML formatted description. And for those of you unfamiliar with React, dangerously set inner HTML is an HTML property that allows developers to programmatically set HTML elements from an external source. So dangerously set inner HTML helps React to know how to handle the HTML elements in a component where the contents are to be rendered. Now, the security challenge with using dangerously set inner HTML is that it can expose the web application to cross-site scripting attacks if the data being rendered contains malicious scripts. To avoid this scenario, the developer decides not to trust the data coming from the e-commerce provider's API without first sanitizing it. This is the React component, which displays detailed information about the product. It shows the product name, the description, and pricing. And in this product details component, the product description is rendered using dangerously set inner HTML. So the developer can use a free library called DOMPurify to sanitize the HTML, like I'm showing in this code snippet. This removes any malicious scripts or code that could lead to cross-site scripting attacks. Now, this is a client-side component, but on the server, it would be similar, just using JS DOM additionally, because that makes the DOM available server-side. Now, an even better option that the developer could go about this would be to render Markdown instead of raw HTML. So many headless e-commerce platforms support getting the description in Markdown, so the developer can completely sidestep HTML parsing and not use dangerously set inner HTML at all. And this is safer as it eliminates the risk of cross-site scripting. In this code snippet, I'm showing how Markdown is converted into React and sanitizes any stray HTML that sneaks in. So as I said earlier, threat modeling is not a one-time event. So even after writing the code, a dev can use a static application security tool to find potential security vulnerability in their code and fix them. I use SEMGREP as it's free for small projects and has a good rule set for JavaScript or React. But you can use whichever SaaS tool you like, as long as you find it easy to integrate in your IDE and your overall workflow. This way, you actually use it and you avoid the mental fatigue due to context switching between developing and securing. For visual purposes, I'm showing here the dashboard view, but for a developer, using the CLI is more convenient. If the developer were to keep the initial unsanitized code, the SAST tool would have helped the developer identify the use of dangerously set inner HTML as a potential cross-site scripting vulnerability. In this scenario, as a developer, you can take the following protective measures to prevent unsafe consumption of APIs. So first of all, practice secure coding and use the security features of your framework. For example, if you're working in Next.js like I do, you can set React strict mode to true in the next.config.js file, or specify the remote host names and protocol in the images property to ensure that only images from trusted sources are loaded. Additionally, one can set a strict content security policy that disallows inline scripts and further helps mitigating the risk of cross-site scripting. Just like the case with user input, do not trust the upstream API data, instead verify it. And if you're also in the JavaScript ecosystem, you can use TypeScript to define strict types for the data you expect from the API. And this helps you catch any unexpected data structures or types that could lead to vulnerabilities. 3. Assume upstream API providers are part of your supply chain. Evaluate their security posture and frequently update the NPM packages you use. To identify vulnerabilities in your dependencies, you can use npm audit if you're working in a JavaScript environment, or you can enable GitHub's Dependabot or use a software composition analysis tool of your choice. For example, SEMGREP, OWASP, Dependency Check, Snyk, and so on. Fourth, create and maintain an inventory of every third-party API you interact with. To create this inventory, you can use Postman collections or self-host your API catalog with a static site generator like Docusaurus, which is a React-based documentation framework where you can render Markdown and open API specs side by side. And additionally, drawing from the Hugging Face incident, safely manage the API keys that your web app uses to communicate with the e-commerce backend. Do not store them or sensitive config files in public repositories. Do not share keys via unsecured channels such as chat, and do not store keys in client-side code. Instead, use environment variables or even better, secret management tools, sorry. Now, here I have an extended scenario. So based on that simple web application that I described earlier, we can extend this by integrating other third-party APIs from sellers, but I think we're running out of time, so I will not go into the details. So in here, what could go wrong is that an upstream API is compromised or vulnerable to excessive data exposure. And if our app does not validate the data received from this API, the marketplace could be at risk of data breaches. And to prevent this, the developer could use which is a free schema validation library for TypeScript, and defines Zod schemas for the expected structure of the API response. So when the data is fetched from the API, it's validated against these schemas, and if it doesn't confirm with the expected structure, an error response is thrown in instead. This way, even if the third-party API is vulnerable to excessive data exposure, the app only processes and exposes the fields defined in the Zod schemas, thus minimizing the risk of sensitive data being sent to the front end. So, as you may notice, the threat modeling exercise helps a developer identify protective measures that vary based on the specific third-party APIs and their use cases. We've only looked at a few simple examples, but the key here is to cultivate this mindset of identifying the potential risks with integrating third-party APIs and aid your efforts with tools that catch vulnerabilities before they turn into real problems. Now, to reiterate everything that we've covered in this session, security is relevant whether you work at a company of 2 people or 2,000. Learning to think an attacker will make you a better developer. Threat model your apps before writing a single line of code. Think of security as a feature. This protects your work, your client's business, and their customer data. And lastly, treat any third-party APIs as unsafe and ensure that your app consumes it as safely as possible. With this, I thank you for your time and attention.
That was amazing. Definitely go connect with Roxana on LinkedIn, and you should absolutely go follow her on devroxana.com. It's been such a pleasure learning from you today. Thank you so much.
Thank you so much to everyone who tuned in for my session. And I hope, yes, that if you're a front-end developer, that I brought you a bit of security awareness, and then you can start to look at your project with a bit of different lenses, let's say.